Here at the BRANDT Research Farm, we're putting agronomic strategies to test and sharing insights to give you the info to grow. Today we'll be talking about starter fertilizers, why they matter, how they help your plant on the early development, and what are we testing at the research farm this year. So why is early nutrition so important, and why do we usually see the yield advantages when we utilize a starter fertilizer? If you look at a graph like this, you see that the nutritional requirement early on is quite low. So you might be wondering, should we even worry about utilizing the starter fertilizer? Well, one thing we can't forget is the size of the root system early on. It is very small. So even though the total amount of fertility required is not high, the amount that has to pass through that small root system is quite significant, and it has a huge impact on crop productivity. So the moment the seed starts to germinate, the plant will start sensing the amount of nutrition it has available, the amount of substrate it has available for that season. And based on that, it will set the yield potential. How many kernels can I support with this amount of fertility that I have available? So that's why it's so important to have high fertility levels. For corn, for example, we know that around V5, V6 will have the number of kernel rows being determined. From V10 all the way to V12, we'll have the length of those ears being determined. So having appropriate fertility means that we'll maximize kernel number, and with that we can maximize yield at the end. Some key nutrients to pay attention to at these early stages are nitrogen. We want high nitrate availability around the rhizosphere to maximize yield potential. Phosphorus, super important as well, and sulfur and zinc, all very important nutrients. Not saying that the other nutrients are not important, but these usually are the nutrients that are most limited throughout this early season. One of the main reasons we see low availability of some of these nutrients like nitrogen, phosphorus, and sulfur is because a lot of these nutrients are found in the organic form in the soil. We know that 90–95% of the nitrogen is found in the organic form in the soil, the same for sulfur, 90–95%, and for phosphorus it can vary quite a bit. But here in Illinois, for example, we know that on average 50+% of the total phosphorus in the soil, it's in the organic form. That means that we need these nutrients to be mineralized to become plant available. And when we're planting, what are we getting out of? The winter. Cool soils with low microbial activity. With low microbial activity, it means that we have low mineralization of these nutrients. So we're planting early, but these nutrients are not available. And that's when we usually see the greatest response to starter fertilizer, when we're planting early and when we utilize these nutrients that are organically bound in the soil. For micronutrients, it's quite interesting. Even though zinc, manganese, iron, or other micronutrients are not organically bound, they can get trapped in the organic matter, trapped in the CC of the organic matter. And we know that when the organic matter mineralizes, it also releases these micronutrients. So organic matter mineralization has profound effects on nutrient availability, and the earlier you plant, the lower nutrient availability you'll have because the soils are still cool. Another thing that is interesting when you're planting in cooler soils is the lower diffusion of nutrients, especially nutrients that are immobile in our soil, such as phosphorus, potassium, even calcium, magnesium. They get to the root by diffusion. Under cooler temperatures, we know that diffusion rates are slower. How can we overcome that? By increasing the concentration of these nutrients. So by applying a starter fertilizer, we increase the concentration, we increase the diffusion rate of these nutrients towards the root, and we make the plant get access to it a little bit better. However, there are some things that you gotta pay attention when utilizing a starter fertilizer. The first thing is the rate that you're applying, especially if you're applying in furrow. You gotta be cautious about the amount of salts you're applying. Too much salt can cause some injury to the seed, can delay seed germination, and can cause some emergence problems. So if you're gonna work with higher rates of starter fertilizer, maybe applying that higher rate 2x2, 3x3, 2x2x2, it's a better idea. Also, when utilizing phosphorus starter fertilizer, this is very important and we've been seeing this over and over in our research. When utilizing phosphorus fertilizer, pair it with a zinc source, preferably a chelated, a protected zinc form. And why is that? So there's two reasons why we want to apply phosphorus or we want to apply zinc when we utilize phosphorus. The first is that zinc and phosphorus can precipitate in the rhizosphere. So by applying that phosphorus starter fertilizer, you're inducing zinc deficiency. We don't have a whole lot of zinc in the soil. Whenever we apply that phosphorus fertilizer, we induce deficiency by precipitating whatever we had in the soil. So by applying some protected form that doesn't react with the P fertilizer, we overcome that induced deficiency. The second cause, or the second reason would be that utilizing phosphorus fertilizer usually inhibits the growth of arbuscular mycorrhizal fungi, AMF. AMF happens to be the main way that the plant gets access to zinc and other micronutrients as well. So by inhibiting the growth of this AMF, you're also indirectly causing zinc deficiency. So that's why we always like to pair phosphorus fertilizer with zinc sources. And what sources of zinc does BRANDT offers for your starter fertilizer? So we have sequester 9% zinc, which would be your EDTA zinc, chelated zinc, protecting it from reactions in the soil. And we also have ENZUP zinc, which is also EDTA chelated zinc plus enzymes, which I'll be talking about later on this video. And we ran trials in several different locations across the Midwest looking at the response to starter fertilizer, in this case APP, ammonium polyphosphate, with or without a zinc source. What we saw is that by applying APP by itself, we were seeing actually yield decrease on average, a slight decrease, but no yield increase. However, when we pair that APP with a zinc source, then we saw the yield advantage, then we saw the yield bump. So that's something we always like to pair our phosphorus fertilizer with a zinc source. But what about specialty formulated starter fertilizer? We talked about APP, ammonium polyphosphate, 1034O. This would be more of a commodity starter fertilizer. There are some issues with utilizing APP. APP, depending on the formulation, will have around 70% polyphosphate and 30% orthophosphate. The polyphosphate that is in APP, it's not plant available. It has to be broken down into orthophosphate to become plant available. And this process of oxidation of polyphosphate depends on temperature, but also microbial activity. So if we're planting on cooler soils, we know that it might take some time for that polyphosphate to become orthophosphate, and we don't want to wait that time. We want it to be readily available when that crop is germinate or that seed is germinating. So that's one disadvantage of using polyphosphate. But are there any benefits to using APP? So as I said, polyphosphate might not be readily plant available, but it also does not react with the soil as much as orthophosphate. So you might see that P available for a little bit longer time until it becomes orthophosphate. But there are other solutions that BRANDT now offers that might even improve the utilization of your APP or can be replacing your APP as a starter fertilizer, and that's ENZUP PDS. So what is ENZUP PDS? ENZUP PDS is an orthophosphate-based starter fertilizer plus enzymes. And what are enzymes? Enzymes are biological catalysts. They increase the rate of a reaction. And in this case, for ENZUP PDS, we have two different enzymes, mannanase and phosphatase. What are these enzymes doing? So mannanase will break down the mannan linkage in some carbohydrates. By breaking down these complex carbohydrates into simpler forms of sugars, these sugars can feed the soil microbiome. So we can kind of give an espresso shot to these microbes in the soil by providing them energy from the breakdown of these carbohydrates. The second enzyme, phosphatase, breaks down organic phosphorus into orthophosphate. So as I said, a lot of our phosphorus in the soil is in the organic form, from 50 all the way to 95% of the total phosphorus in the soil is in the organic form. But this organic form is not plant available. It gotta be broken down into orthophosphate. And the only way for that to happen is through the use of enzymes. So enzymes are naturally produced in your soil by microbes, by plant roots, and other fungi also will produce some enzymes. However, we're planting in cooler soils, we know microbial activity is not high, we know that the concentrations of these enzymes are not high. So what do? We go there and apply a concentrated solution of these stable enzymes in furrow, releasing organic phosphorus, releasing energy for those microbes in the soil, kind of giving a jump start in your soil from this early planting. So we've compared 1034O or APP to NZAP-PDS, 5 pounds of NZAP-PDS, and we saw that NZAP-PDS actually gave us a yield advantage when compared to APP alone. However, one interesting combination that we did was 2.5 gallons of APP plus 2.5 pounds of NZAP-PDS. And we saw that that was better than any of those two products alone. So we see a synergistic effect of applying a little bit of that polyphosphate with this enzyme solution. So very interesting product if you're looking into increasing your phosphorus availability early on. We also have another product called NZAP-KDS, which instead of phosphorus will have potassium, but also paired with those two enzymes, phosphatase and manganese. This is a very interesting product if you're in soils with low potassium availability, and you want to increase that potassium availability early on. We actually tested this product last year with Dr. Dan Quinn from Purdue University in a trial where we were varying the rate of potash applied with or without the use of NZAP-KDS in furrow. So this site was a site very low in potassium in the spring. We were reading only 28 ppm in the soil test for potassium. So you can expect that this field would be very responsive to potash application, as you can see in this graph. But it's interesting to see that NZAP-KDS increased yield in all different potash levels, not only on the limited potassium availability at the low rates, but also at the high rates. Of course, responses were greater under low potash rates because then you get more response from that K applied in furrow. So what are we testing this season here at the research farm when we talk about starter fertilizers? We're comparing traditional starter fertilizer, your commodity 1034O, to our specialty formulated starter fertilizer, NZAP-PDS, NZAP-KDS. We'll be testing those products at the farm. We'll again be looking at the interaction of starter fertilizer with phosphorus and zinc, see how those are interacting, looking at different zinc sources, see if zinc source has an effect in that. We're also looking at molybdenum as a starter fertilizer. We've been seeing from our research that the crops, corn and soybean, are very responsive to moly, and we want to see if there is any response to utilizing moly in furrow. And we also will have trials looking at different starter fertilizer sources, how they're impacting early season biomass production and also early season nutrient uptake. We'll be collecting some samples, looking at total plant uptake to see if there's any advantage of using one source or the other. So to summarize why starter fertilizers are so important. So we know that we need that early season fertility to maximize yield potential, but we have a small root system. So we gotta place that fertility better. We can do that with starter fertilizer. When do we expect to get the biggest response from starter fertilizers? When we're planting early into cooler soils with low organic matter mineralization, especially if you're running a starter with nitrogen, phosphorus, and sulfur in it. Does source matters? Yes, it does. We can improve our starter fertilizer even more by utilizing premium sources such as Enza PDS or Enza KDS, which not only have nutrition but will also be adding some enzymes to activate, jumpstart that soil activity, releasing nutrients that would not be plant available unless we utilize some of these enzymes. But what if I don't have a liquid starter fertilizer system in my planter? Are there any alternatives to achieve the same results? Well, I'll tell you that there is. And actually, Dr. Eric Winans will be talking about it later this week. So stay tuned for his video on planter box treatments.